In this section, we are going to look at what is probably the most important section of all, ownership and permissions. Before we discuss ownership and permissions, we need to look at the list command in more detail. You need to be familiar with the information that the ls command displays. The ls-l command displays a wide, detailed listing of the contents of a directory. Here we have a directory listing of the root directory. The ls-l command was typed to display a long listing of the root directory. The total line displays the amount of disk space used by the files in the list. The first column displays what is called the identifier and the permissions. The second column displays the number of links. We will look at links shortly. The third column displays the ownership. The fourth column displays the size of the file or directories. The fifth column displays the date and time that the file was created or last modified. And finally, the sixth column displays the name of the file or directory. Let's look at each column in more detail. At the top, we have the command that was typed, ls-l, to list the contents of the root directory. The total displays the amount of disk space used by the files in the list. The first column is broken up into 10 characters. The first character is the identifier. It identifies if the entry is a file, directory, or symbolic link. Looking down the list, we can see mostly Ds. Those are directories. A dash indicates files, and a L indicates a symbolic link. Directories are used to store and organize files on your storage device. You can regard a symbolic link as a shortcut to a particular file. The next 9 characters, the R, W, X, and the dash, refer to the permissions. We'll look into permissions in more detail shortly. The second column displays the number of links. A directory is nothing more than a file that contains information about other directories and files. So when you create a directory, you are creating a new file of type directory, and automatically 2 entries are created. A single dot or a single period refers to the directory itself, and a double period refers to the parent directory. So automatically, when you create a directory, the count that we referred to just now will be 2. The command mkdir is used to create a directory. So I've typed mkdir, and I'd like to create a directory called test. A wide listing displays the directory I created, test, and look at the count. It is on 2. Let's use the change directory command and change to the directory test. Dot entries are hidden. We need to add the A flag to display hidden files and directories. As discussed previously, when you create a directory, automatically 2 entries are created. Single period refers to the directory itself. Double period refers to the parent directory. I'm inside the test directory. I'm going to create a new directory. I'm going to call that directory sub. I'm going back 1 level to my home directory. So we have the directory test, which we created. The count was automatically 2. Inside the test directory, I created a new directory called sub. Notice how the count is now increased to 3. There are the 3 entries inside the test directory. So the test directory is displaying a count of 3. When we look at the ls-la test, you will notice the double period, which refers to the parent directory, has a count of 9. A listing of my home directory indicates we only have 3 directories. If I add an A to display hidden, count the number of directories. 2, 3, 5, 6, 7, 8, 9. 2 periods at the top, period, double period, .cache, .config, .local, .ssh, MySQL Tuner, bash scripts, and test. So those are your directory links. The third column displays the ownership. On the left is the owner, and on the right is the group owner. We will get to ownership shortly. The fourth column displays the size of the file or directory. Remember that a directory is simply a file with information about the files contained in that directory. The fifth column displays the date and time that the file was created or last modified. The sixth column displays the name of the file or directory. For the purposes of this course, only the first, third, and sixth columns are of interest to us. Here is a listing of the /etc/nginx directory. Can you identify the files and directories in the listing? You will notice in the identifier column Ds and dashes. The D indicates a directory, the dash indicates a file. We will look at the permissions shortly. Let's look at ownership. With reference to directories and files, there are two types of owners: the actual owner and the group owner. There is also what is called the other user. The other user is not an owner, but needs to be discussed. The wide or long listing displays the ownership. On the left is the owner, and on the right is the group owner. Any file or directory created by a user is automatically owned by that user. Now we have the group owner. Groups are used to organize users on a server. Think of a situation where 5 people need to edit a certain file. You create a group, you add those 5 users to the same group, and then allow the group as a whole to write to the file. It's convenient and very easy. The other user is a user who didn't create the file and is not part of the group that owns the file. Think of the example of the 5 users added to the same group and that group being able to edit a file. You didn't create the file and you are not part of the 5 user group, so therefore you are what is called the other user. How the owner, group owner, and the other user relate to each other, and the importance of being able to identify various owners and users will be looked at in the next section on permissions. Now we get to permissions. Ownership refers to who owns the file or directory. Permissions specify what privileges a particular user has on files and directories. By privileges, I'm referring to what a user may or may not do with respect to a file or directory. By saying may or may not do or referring to privileges, I'm talking about the ability to perform certain actions like reading or writing files or directories. When it comes to Windows, you can copy and move files and directories without thinking twice. On a Linux system, things are very different. You need to have the relevant permissions on files and directories to perform certain actions. Here is an example of permissions at work. We are going to cover everything in detail in this section, so please bear with me. The user Andrew wants to copy a file, abc.zip, to the /var directory. A message, permission denied, is returned. The reason for this is that the user Andrew doesn't have right permissions in the var directory. This is how permissions work. They restrict what actions a user is allowed to perform. There are 3 types of permissions: read, write, and execute. They are abbreviated in lowercase as R, W, and X. These permissions refer to both files and directories. Let's look at file permissions. Read means a user can view the contents of a file. Write means a user can modify or delete files. Execute means if a file is a script or program, the user can run the script or program. Now we have directory permissions. Read permissions mean a user can list the contents of a directory. Write permissions mean a user can create or delete a directory and create, edit, delete, rename the directory contents. The user also needs the relevant permissions on the files. Execute permissions allows a user to enter the directory. Please pause the lecture, make a note of the definitions listed for permissions on files and directories. We need to look at the list command again. Here we have a listing of the /etc/nginx directory. The first column consists of 10 characters, the first being the identifier, the next 9 characters being the permissions on the particular file or directory. The first character identifies the type of entry in the list, a file, directory, or symbolic link. The next 9 characters are the permissions on that particular file or directory. These 9 characters are broken up into groups of 3. The first 3 refer to the owner, the second 3 refer to the group owner, and the last 3 to the other user. The read, write, and execute permissions are clearly visible, RWX. When you see a hyphen, that means there are no permissions in that context. So R hyphen means read, no write, no execute. Here we have the same listing of the etc nginx directory. I've highlighted a file and a directory. Let's look at the file nginx.conf. First 3 permissions are W hyphen. That's the owner. The group owner is R hyphen. The other user is R hyphen. What does that mean? The owner, the root user, can view the contents of the file and edit the file. The group owner, which is the root group, can only view the contents of the file nginx.conf. The other user can only view the contents of the file. Look at the directory sites available. RWX, R-X, R-X. Now what does that mean? The owner root can enter the directory, that is the X. View the contents of the directory, that is the R. Edit, delete, and rename the contents of the directory, that is the W. The root group can enter the directory, that is the X. View the contents of the directory, that is the R. The other users can enter the directory, that is the X. View the contents of the directory, that is the R. Permissions can be expressed in decimal notation. Read has a value of 4, write has a value of 2, and execute has a value of 1. No permissions, the hyphen has a value of 0. You read the permission value as follows. The first digit refers to the owner, the second digit refers to the group owner, and the third digit refers to the other user. What does a permissions value of 664 mean? The owner can read-write, the group can read-write, and the other users can read. You add the permission values together. So RW would be 4 plus 2 plus 0. R would be 4 plus 0 plus 0. So you end up with 664. Here we have permissions of 775. Look at the owner. Read, write, execute, 4 plus 2 plus 1. The group owner. Read, write, execute, 4 plus 2 plus 1. The other user, 4 plus 0 plus 1. We end up with permissions of 775. Let's apply that to an example. Here we have the /etc nginx directory. The file nginx.conf has permissions of rw hyphen, r double hyphen, r double hyphen. Let's add that up. The owner, rw hyphen, is 6. The group, 400. The other users, 400. So we have 644. The directory, sites available. The owner, rwx. 421, that is 7. The group owner, R-X, 401, that's a 5. The other user, R-X, 401, so that is 755. What does a permissions value of 644 mean? Well, 6 automatically is 4 plus 2, read plus write. That refers to the owner, so the owner can read and write. The 4 for the group means read. 4 for the other user means read. So 644 means the owner can read write, the group can read, the other user can read. Permissions of 755. The 7 refers to the owner. The 5 refers to the group owner. The last 5 refers to the other user. 7 RWX, 4 plus 2 plus 1. The group owner is 5. 4 plus 1. The other user is 5. 4 plus 1. Permissions of 755. What would permissions of 400 mean? The owner is 4. That means the owner can read. Group owner have no permissions, other users have no permissions. 400 is often used to lock a file down if you want to prevent any other user from reading the contents of the file or modifying the file or executing the file if it's a script. Now we have permissions of 777. What does 777 mean? It means the owner, the group owner, and the other user have read, write, and execute permissions. The file is wide open. All users have full access to that file or directory. They can read the contents of the file, they can modify the file. If it's a script, they can run the script. If it's a directory, they can view the contents of the directory. They can modify the contents of the directory as well as enter the directory. Do not give any file or directory permissions of 777. 777 permissions allow any user on the server to read, write, and execute. It is extremely foolish to use 777 permissions on any file or directory. Never give any file or directory 777 permissions, even temporarily. This is normally an indication that there is a problem with the configuration. Fix the configuration and don't try to find the easy way out by using 777. There are no shortcuts and easy fixes when it comes to server security. It must be done correctly from the word go. Here are a few commands regarding ownership and permissions. Just make a note of the commands. I'll explain how they are used later in the course. When we want to change permissions, we use the command chmod. When we want to change the ownership of files and directories, we use chown. When we want to change or switch from one user to another, we use the su command. I cannot emphasize the importance of understanding ownership and permissions. Getting the ownership and permissions correct is an important step in creating a secure environment to host your WordPress sites. I want to repeat one last time. Do not use 777 permissions to try and correct a configuration issue. Fix the configuration issue instead. Ownership and permissions can be confusing if you are new to Linux, but there is no need to worry too much about it at this stage. We will be looking at WordPress ownership and permissions in much more detail after we install a WordPress site. As per the WordPress Codex, the correct ownership and permissions for a WordPress site is as follows. All directories should be owned by your user account and group owned by the web server. They should be writable only by your user account. Any directory that needs write access from WordPress should be writable by the web server. Without understanding ownership and permissions, the above paragraph won't make much sense, and you will probably set your ownership and permissions incorrectly. We will follow the codex and use the principle of least privilege. We will look at WordPress ownership and permissions in detail once we install our first WordPress site.